Hey guys, this is the exam 3 study guide. Again, as you go through these questions, every question on the exam would be a form of one of these questions. So if you can do this review, you are ready for the exam. Number one says, which graph shown below is the graph of the following function? And then they give us f of x is equal to x squared plus 5. So I know in in unit 2, we talked about transformations. And you can use that information if you want, that table of how parent parent functions are transformed when you add or multiply or make the term negative. Um, and if we go by that table, we know that the parent function is going to be x squared. So first I would think about what is the graph of f of x equals x squared. And that graph is always going to look like it's going to have a point at 0, 0 when x is 0, y is 0. So it'll have a point here. When x is 1, 1 squared is still 1, so it will be right here. And then when x is negative 1, negative 1 squared is still 1, so that'll be here. So the graph of f of x equals x squared just looks like this and goes through the origin, okay? So that's the parent function, and then we're going to add 5 to it. Notice that, remember the difference between adding it to the entire function and just adding it to x. The adding it to x looks like this. F of x equals x plus 5 inside the parentheses squared. Okay, that's the difference. So this is, we're adding 5 to the entire function, or we're adding 5 to y. So that means we're going to go up 5 on y, because this would mean we move to the left or the right on x on the x-axis. This means we're going to move up 5 on y. So we're going to take this graph, and instead of 0, 0, we're going to have 0, 5 as our starting point and have the exact same graph, just a little bit higher. So that would be letter A. We good? And I didn't really count that. It looks like the scale is from negative 12 to positive 14. I didn't count it, but I see that this one's going left, this one's going right, and this one's going down. So really the only option that goes up is A. If you have two different ones, just make sure you count carefully. If the graph has a big even number, that means it's probably counting by twos. So this is negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, if you are counting. All right, we have a similar question. Match the graph with the following function. F of x equals negative x squared minus 8. All right, so again, our parent function for that is f of x equals x squared, that one. F of x equals x squared is this right here. And then we're going to make it negative. What happens if we make it negative? If we make that x squared negative, we flip it. And we're going to subtract 8 from it. So when we added 5 to it, we went up 5. When we subtract 8, we go down 8. So it's going to be opening down, and it's going to be down here. Good. So that looks like the only option it could be is E. And I think, in fact, we should probably go backwards. So we should probably start with taking that x squared. We should move it down first and then make it negative, if that matters. Okay, now they're going to give us a quadratic function. We need to find the vertex and the axis of symmetry of the quadratic function for part A. So it will ask us, what is the vertex? What is the axis of symmetry? The first thing you need to do, I don't ever feel like this is enough in focus. The first thing you want to do is determine whether they have given you the quadratic function in standard form, factored form, or vertex form, okay? So standard form would be y equals, or f of x equals ax squared plus bx plus c. That's standard form, okay? It does not look like it's in standard form. The other form is vertex form. Vertex form, and I'll use f of x because I should have used f of x up here. F of x equals x minus h squared plus k, good, where h is equal to the x value of the vertex and k is equal to the y value of the vertex, because a vertex is that the very middle of your parabola. So this would be the vertex of x squared, this point, the highest or lowest point that's right in the middle. Good? All right, so that's standard form, and this is the vertex form. It looks like we're in vertex form because we have f of x equals parentheses x minus, and then we have a number squared, and then we have plus, in this case it would be plus -4 for k. Okay, so we have identified that it's in vertex form, and then the way you're going to write the vertex is hk, the point hk. Does that make sense? Okay, so in our case, up here, h is 3, and k, notice the plus sign that's part of the equation. K is going to be -4 because we're adding a -4. So I'm going to say my vertex is 3, -4. And they ask you here to put in an ordered pair, and that's what they mean, the x and then the y. The axis of symmetry. Remember, the axis of symmetry is just the x value as a line, okay? So we know that that's in the form x, y. The axis of symmetry is just going to be x equals, and then take your x value, take your h, which in our case is 3. Good? So the axis of symmetry is x equals 3. Part B says determine whether the graph is concave up or concave down. The rule for determining whether it is concave up or concave down is when it is in standard form, is A greater than 0 or is A less than 0? If A is greater than 0, it's going to concave up or open upwards, and if A is less than 0, it's going to concave down or open downwards. Now we don't have a graph in standard form right here, so we can put that into standard form if we want. Or you can keep it in this form and start entering in x values and solving for y. Because we know that the vertex is 3, -4, right? So let's graph that. Because the next question is going to be use the graphing tool to graph the function. So we are going to start with the point 3, -4. I'm going to have to look really close on. Oh, this is a nightmare. I think I got it. So that is the vertex. And then we will also, of course, have our line of symmetry, axis of symmetry, which means that the graph is going to be the graph is going to be exactly the same. The points are going to be equidistant from that line of symmetry on either side of the quadratic function. Got it. Good. So there's our axis of symmetry. There is our vertex. And then if you want to just plug in an x or a y, like you could put in, here we have x equals 3. So if I put in x equals 4 for that, I will know where that point is and whether it is above or below. If that point's above, that's going to concave up. If it's below, it's going to concave down. Good? Or we can take f of x equals x minus 3 squared minus 4, expand that and put it into standard form. X times x is x squared, x times negative 3 is minus 3x, negative 3 times x is minus 3x, and then negative 3 times negative 3 is a positive 9, plus negative 4. Sorry, I shouldn't have written that plus, so I'm just making it plus negative 4. And then we can simplify by combining like terms. So we'll combine the negative 3x and the negative 3x to get negative 6x, and then we'll combine that positive 9 minus 4 to get plus 5. We see that that x is a positive, and so we are going to say the graph is concave up. All right. Now it's going to ask us to graph the function. For this, what I would do is I would put 0 in for x maybe and see if I get a good number for y so that I can get a point on the graph. So we've got f of x equals x squared minus 6x plus 5. And I'll put in a 0 for that x. And now I've got 0 squared minus 6 times 0 plus 5 equals, and f of x is y as we know. So now I've got y equals 0 squared is 0, negative 6 times 0 is 0, y equals 5. So when x is 0, so that becomes the point 0, positive 5. Okay, I'm going to put that on my graph. When x is 0, y is positive 5. How far away is that from the axis of symmetry? 1, 2, 3. So I can just go 1, 2, 3 to the other side. And that is the graph of my quadratic function. Um, Obviously, I think they will create the line for you with the graphing tool. Good? All right. Similar question, find the vertex and axis of symmetry of the quadratic function in and it's already in vertex form. So here we have g of x equals negative quantity x minus 3 squared plus 6. Okay? Now this one's a little bit confusing because they do have that negative sign in front, so I'm going to change the vertex form and make it a little bit clearer for you, okay? So it's actually y equals a times the quantity x minus h squared plus k. So right now, because that's negative, because that's that a is equal to negative 1. Okay, so we can still find h and k. H in this case is equal to 3. K is equal to 6. So my vertex is HK. So that's going to be a vertex of 3, 6. Oh, darn it. Sorry. Vertex of H comma K, the point, the ordered pair. And H is equal to 3, K is equal to 6. Because that's negative, you don't need to change that negative 3 to a positive. Okay? So the vertex is 3, 6. The axis of symmetry is always going to be x equals h. And we found h. as the x value of our vertex. In this case, it's 3. So the axis of symmetry is x equals 3. The graph is concave up or concave down. Well, now there's a negative sign in front of here, so that might help us, give us some information. 3, 6, I'm going to find that. And then x equals 3. As our axis of symmetry. Good? All right. The graph is concave up or concave down. Again, you can verify by putting it into standard form. So I'm going to do the power sign before the minus sign. X times x is x squared. And that was all. There was a minus sign in front of all of that, right? So that's negative x squared plus 3x plus 3x minus 9 if I distribute that negative sign. So a negative times a positive makes a negative, negative times a negative makes a positive, negative times a negative makes a positive, negative times a positive makes a negative, plus 6, negative x squared plus 3x minus 9 plus 6. Combine these and combine these, and I get g of h is equal to negative x squared plus 6x minus 3, right? That is concave down. It is going down. Good. And then we need to graph the function. Again, I like to just put in 0 when x. What is y? Instead of g of h, I'm going to call it y. Y equals, sorry, negative, and then instead of the x, I'm putting in the 0 squared. So there's my minus sign, changing the x to a 0, squaring it, plus 6 times 0 minus 3. And I get y equals 0 squared is 0, negative 0. 6 times 0 is 0, minus 3. Does not matter if your 0 is negative or positive, they both disappear. So y equals 3 when x is 0. So a point on the graph is 0 for my x, 3 for my y. I'm going to go put that on the graph. I have this point, and then I have 0, 3. I'm going to count how far away that is from the axis of symmetry. It's 3, so I'm going to move, that was 3 to the left, I'm going to move 3 to the right. And that should be enough information for you to graph it with the graphing tool. All right, I had to stop recording because I did half of number 5 wrong, so I'm starting over. This is number 5. That number was printed on another page that I deleted, so I'll write it there. It says for the quadratic function f of x equals x squared plus 2x minus 15, answer parts A through F. I'll just read A. Find the vertex and the axis of symmetry of the quadratic function and determine whether the graph is concave up or concave down. All right, so we just did with number 3 and number 4, we did find the vertex, but those two equations were already in vertex form. This is in standard form. So standard form is f of x is equal to ax squared plus bx plus c. Good? Just make sure. Okay. Um, and the formula for finding the vertex in this situation is you find the x value first, which is, we know, the x value of the vertex is the axis of symmetry. When they say ordered pair, they mean x followed by y. So we're going to find the x first, or the axis of symmetry first, using this equation. The vertex's x value is equal to negative b over 2a. And it doesn't matter if you put, I just want to remind you because I'm probably going to make this mistake, if you put the minus sign up here with the b or out in front or down here, okay? So if I write it and then I suddenly write it with the minus sign out here in front, that won't change the value. But this is what we have. And then the equation they gave us was f of x equals x squared plus 2x minus 15. So that means real quick that a is equal to 1, b is equal to 2, and c is equal to negative 15. We agree? All right. So to find the vertex's x value, x equals negative b over 2a. The b is 2, so it's going to be negative 2 over 2 times, and what is a? A is 1. Simplify that to negative 2 over 2 times 1 is 2, which is negative 1. So the x value of the vertex is negative 1. That means I can write it right up here. And we're going to now put that x into our equation and find y to find that second half of the ordered pair. And we'll be done. Okay, so coming back to f of x equals x squared plus 2x minus 15 when x equals negative 1. Good. So we found x is negative 1. We found the x value of the vertex. The vertex is just the lowest or the highest point. And then we're going to put that negative 1 in here and find y. Y equals negative 1 squared plus 2 times negative 1 minus 15. Simplify that. Negative 1 squared is a positive 1. 2 times the negative 1 is minus 2 minus 15. Good. And that's why I use the parentheses, just to remember that the whole negative 1 is being squared. Negative 1 times negative 1 makes a positive 1. Positive times a negative makes a negative. 1 minus 2 is negative 1 minus 15, which is negative 16. So when x is negative 1, y is negative 16, and that's my vertex. Sorry, you couldn't see it anymore. Good. I'm going to mark that on my graph, on my coordinate plane. X is negative 1, y is negative 16. Shoot, I'm really bad at my vision, guys. And then, of course, you know the axis of symmetry is just x equals h, and h is the x value of our vertex. So the axis of symmetry is just x equals negative 1. The axis of symmetry is the x value of your vertex. I'm going to add that. Right there. Okay. Next question, is the graph concave up or concave down? It's already in standard form, and we see that it is a positive a, so that means it is concave up. But they're going to ask us to graph it, so you could also just graph it right now to determine that. That was part A. Part B asks us to find the y-intercept and the x-intercepts, if there are any. Remember to find the y-intercept, and this is our equation. To find the y-intercept, set x equal to 0. So we're going to do the same thing as here. This was when x is -1. Now when x is 0. So y equals 0 squared plus 2 times 0 minus 15. And we'll just solve that. 0 squared is 0, plus 2 times 0 is 0, minus 15. So y is -15 when x is 0. X is 0, y equals -15. They're just asking for an integer, so they just want a number. You don't need to say, you don't need to have an equal sign. You don't need to have a pair of points. You just say the y-intercept is -15. Good. The x-intercept, same equation, but we say y is equal to 0 now. So now we have 0 equals x squared plus 2x minus 15. And what I would do is I would see if I can factor it because it is set equal to 0. Okay, so are there any, we're going all the way back to unit 1? Is there any number that will add to equal 2 and multiply to equal -15? Good. So it needs to multiply to a negative, but add to a positive. So if it was -1 and +15, you can't divide 15 by 2. If it is -3 and +5, that would work, right? -3 times +5 is a -15, and then a -3 plus 5 is a +2. So I'm going to say that that factors to x minus 3 times x plus 5. Good. Now what do we do? If we want to find the x values, then we set each of those equal to 3. It's equal to 0. 0 equals x minus 3. Solve for x, so we'll add 3 to both sides, and we say 3 is x, right? And over here we have x plus 5 is equal to 0. Subtract 5 from both sides and get x is equal to -5. So we have two x-intercepts. When y is equal to 0, x is 3 and -5. So I should put it in the other order. Put the -1 first. So here was our y-intercept. When x is 0, y is -15. Our two x-intercepts are when y is 0, x is -5, and when y is 0, x is 3. So it says the x-intercept is or are, type an integer or simplified fraction using commas to separate them. So I'm going to say -5 and 3 because you should always start with this. I should always start with the smaller number. Good? Okay. Use parts A and B to graph the function. So I'll pull it back up to the graph. We have the vertex. I put in the line of symmetry. The y-intercept is -15. So what that means is when x is 0, y is -15. So that's the point I can create. X is 0, y is -15. Guess it shouldn't be red because my axis of symmetry is red. So it's that point. And then the x-intercepts are -5, 0, and 3, 0. So I'm going to graph both of those. Good? Okay, so now you've got this point, this point, this point, and this point to graph the function using the graphing tool. Find the domain and the range of the quadratic function. So here's what we know about it. Kind of a shoddy drawing, but I know that the domain, right, are the x values. So on x, is it going in this direction? There's an arrow, so that means it's going up and to the negative direction forever. It's going up this way, so it's going up into the positive direction forever. So I'm going to say the domain is from -infinity to infinity. So even if it's like a super narrow parabola that's barely going out at all, it is those arrows mean forever, so you still get to say -infinity to positive infinity. It never stops. The range are the y values. So let's look at the y of this graph. Y is up and down, so it is going up forever. Remember, that's always your second term in your interval notation. So it is going on forever. It's not going down forever, however, right? What's the lowest it goes? The lowest it goes is the vertex. So the vertex is the x value, the y value of the vertex is -16. So that means it does not ever go lower than -16. It goes from here up forever. So I'm going to say includes and starts with -16, goes on forever. Good. Where is the interval increasing? It is increasing. So when you were thinking about increasing, I want you to imagine hiking along the graph of the function. Increasing is anytime you have to go up. Okay? Oh, shoot, I wasn't even on. You're hiking, you're hiking along the graph of the function. Anytime you have to go uphill, that's increasing. Okay? And then they're asking you to answer in interval notation, and they only ever want, right? Increasing and decreasing means we're looking at the x-axis like a regular number line, okay? So we're just looking at x's. What is the x equal to when we start going up? And what is the x equal to when we stop going up? That will be the interval, okay? So if I'm looking across this graph, this means -infinity, right? So from -infinity, we are decreasing. When do we stop decreasing? We stop decreasing at the vertex. Okay? So do we stop decreasing at -16 or do we stop decreasing at -1? Remember, you just have this line graph. The lowest point, is that at -16 or -1? It's just this line graph, so it's -1. Okay? So we're going from -infinity to and including -1 that we are decreasing. -infinity to -1, we are decreasing. We are going down. And then at -1, we start going up again. So from -1 forever, we are increasing. We are going uphill. So from and including -1 to infinity. We start at -1 and we go on forever, increasing. Good. Decreasing, same thing. So we started decreasing at -infinity, and we will stop going down and start going up at x equals -1, which is the x value of our vertex. And it will include that because it was still going down until we hit -1. Determine where, part F says determine where f of x is greater than 0 and where f of x is less than 0. I need a bigger graph, right? F of x means y, where y is greater, where y is greater than 0 and where y is less than 0. Okay? That means I'm going to draw a line right at my x-axis. Everything above here is f of x greater than 0. Okay? I guess it just is a multiple choice. F of x is greater than 0. So where does it cross? It crosses at the x-intercepts. This x-intercept is -5, 0. And it crosses at 3, 0. Okay, so when is it going up? It says type your answer in interval notation. So the interval notation of where it is above that line is from -infinity up until -5. And from 3 forever. Now, this is difficult. When you are increasing or decreasing, you always use the brackets. When you are talking about greater than or less than 0, negative and positive, you do not use brackets because it stops right at -5. -5 is where it's becoming 0, so it's not including -5. 3 is where it's becoming 0, so we don't include 3. Okay, so it's a little bit different formatting for the interval of where it's positive and where it is negative. Okay, so f of x, I'm going to write down here, f of x, I'm just rewriting what we already wrote. F of x is greater than 0 at, or on, they say on the interval -infinity to -5 and 3 to infinity, right? And up here at the graph, I wrote and. The symbol for and is that big uppercase U. Okay? And then we're going to find out where f of x is less than 0. Okay, where it's under that line. On, so it's above the line from -infinity to 5 to -5, and from 3 to infinity. That means it is less than 0 on from -5 to 3. That point to that point. Good. So for our answer choices, it's kind of easier if you just look at your own paper because you have 3 multiple choices, but when I printed it, it printed on 2 different pages. So we've got f of x is greater than 0 on -infinity to -5 united with 3 to infinity, and it's less than 0 on -5 to 3. So f of x is never positive. That's not true. Never negative. That is also not true because we've got negative here, positive here. So we're going to pick answer choice 3. C and say f of x is greater than 0 on negative infinity to negative 5 united with 3 to infinity. And it is less than 0 on negative 5 to 3. Good? All right, so that's the end of number 5. That's a big one. Number 6 asks, determine without graphing whether the given quadratic function has a maximum value or minimum value and find the value. Straighten that. All right, this is in standard form. Remember, standard form is f of x is equal to ax squared plus bx plus c. And if a is positive, it's going to be a minimum value, right? Because that's going to open up. It's going to concave up. So that is going to be a minimum value. If it is less than 0, so you have a negative a squared, that means it's going to open down. And so that is your maximum value. Because we're talking about that guy right there. Is that guy the minimum point, the lowest point on your quadratic function, or is it the highest point on your quadratic function? So the quadratic function has in this case, it is positive, so it has a minimum value. And what is that value? The minimum value, we are going to find the vertex of 6x squared minus 12x using our formula. So the x value of the vertex is negative b over 2a, which becomes negative 12, so that's a positive 12, over 2 times 6 equal to 12 over 12, which is 1. Good. So the vertex is 1, and then we're going to find our y, we're going to put that in for x. So when f of x is equal to 6 times 1 squared minus 12 times 1, and we'll simplify that. 1 squared is just 1, so f of x, or y, is equal to 6 times 1 minus 12 times 1 is negative 6. So our y is equal to negative 6 when x is equal to 1. So our point is 1, negative 6. And the value, the minimum value, the smallest it will get, is that point right there, which we have found is 1, negative 6. We want to know how low it gets. Is low going to be the x value or the y value? The x value tells you where to move left to right. The y value tells you where to move up or down. So we're going to take the y value. The value is negative 6. Good. So what you want to do is determine whether it has a minimum or maximum by whether this is positive or negative, and then find the y value of that vertex. Good. All right, number 7. We're going to use transformations of the graph y equals x squared to graph the function. F of x equals the quantity x plus 3 to the fourth. What transformation is needed to graph the function f of x equals the quantity x plus 3 to the fourth? The graph of y equals x to the fourth should be shifted vertically up 3 units. That would be y equals x to the fourth plus 3, right? If I was shifting vertically up 3 units. The graph of x to the fourth should be shifted horizontally left 3 units. That would be y equals, left is negative, right? Y equals x plus 3 to the fourth. Why? Because we do the opposite, right? Left is negative, but inside the parentheses, we do the opposite, right? And this is from the last unit. So that would be shifted horizontally left 3 units. Or we've got the graph of y equals x to the fourth should be shifted vertically down 3 units. So that would be x to the fourth minus 3, because we're going down 3. So that's a negative. Vertically up 3 would be up positive, right? So up positive means we add it outside the parentheses. Down negative means we subtract the 3 outside the parentheses. Horizontally to the negative direction means we add 3 inside the parentheses. In our last one, and for horizontally, right, it'll be positive, right? Right 3 units would be y equals, if it's horizontally, we're keeping it inside the parentheses. Right 3 units is positive 3, so we're going to do the opposite, minus 3 to the fourth. So our correct answer is B. It shifted horizontally left 3 units. Now use the transformation of the graph of y equals x to the fourth to graph f of x equals x plus 3 to the fourth. So we already said that it's shifted horizontally left 3 units. Okay, so here's mine. Okay, so it looks like this one it went up, this one it went down, this one it went left, this one it went right, right? So I'm going to say I chose left 3 units, so I'm going to choose C. Okay, we're going to do that one more time with number 8. Use a transformation of the graph of y equals x to the fifth to graph the function. I'm just going to go down the list again. What's happened is x to the fifth, 7 is being subtracted from x to the fifth outside the parentheses, right? So the graph of y equals x to the fifth should be shifted horizontally right. Horizontally right 7 units would be f of x is equal to, if it's horizontal, we're going inside the parentheses, x. We're moving in the positive direction, so we have to do the opposite inside the parentheses to the fifth. I wanted to just square it, but it's to the fifth. Good. Next, we've got the graph of y equals x to the fifth should be shifted horizontally left 7 units to the negative direction. So that would be f of x is equal to, so we're shifting it horizontally left, we're shifting it in the negative direction, means inside the parentheses, and you do the opposite of the negative direction. So opposite of negative would be positive, so that would be f of x equal to the quantity x plus 7 to the power of 5. Next one, the graph of y equals, oops, I was doing f of x. Y equals x to the fifth should be shifted vertically down 7 units. So that's minus 7. Y equals x to the fifth, because if it's up or down, we keep it outside the parentheses. Down means minus 7. Good. And that last one, the graph of y equals x to the fifth should be shifted vertically up 7 units. Y equals x to the fifth up 7 units. Which one was it? It was this one. So I'm going to choose C. And then again, I'm just going to look at what options they give me. Here is my y-axis, just so that I can see it. And I guess here's my x-axis. We took it and we shifted it down 7 units. So instead of having that center of the 3 points going through x 0, 0, it's now moved down 7 units. Number 9 has a few more steps. Okay, and when you are applying transformations, so we have more than one here, right? F of x equals the quantity x minus 4 to the fifth plus 3. What you want to do is you want to, if you are graphing it by hand and it has more than one transformation, go in the order of operations, okay? So start with the inside the parentheses, then deal with any multiplication, then deal with any negatives, and then addition and subtraction. All right, so the first part that we're going, sometimes it doesn't matter, but sometimes it does. So the first part we're going to address is x minus 4 inside the parentheses. F of x is equal to x to the fifth becomes or transforms into f of x equals x minus 4 to the fifth. Um, what does that mean? Negative 4 means it's either going left or right, right? A negative goes left, but remember, inside the parentheses, it's always opposite. So this is actually going to move right 4. Okay? So from the origin, we originally had it at the origin. Now it's going to go right 4. So it's going to go that direction. Now we have that same equation, and then we're going to add 3. So from f of x equals x minus 4 to the fifth, we're going to add 3. What does that do? Outside the parentheses means it's going to go up or down. That's a positive, so it's going to move up 3. Which graph moves the origin right 4 and up 3? So it started here. We need to move it right 4 and up 3. Good? Okay. Form a polynomial whose zeros and degrees are given. It is a degree 3 polynomial with the zeros -3, 3, and 8. For this one, I would transform each of those zeros into a factor, right? So if the 0 is -3, that means x equals -3. So that means 0 equals x plus 3. Because if I was to solve that, 0 equals x plus 3, and I subtracted 3 from both sides, I would get -3 equals x. Okay, so I'm taking that 0 and I'm translating it to a factor. For x equals 3, it's going to be 0 equals x minus 3, right? And then 8, x equals 8, it's going to be 0 equals x minus 8. So my polynomial is those 3. X plus 3 times the quantity x minus 3 times the quantity x minus 8. Good? All right, same thing here. If the 0 is a negative, then that means -3 means it's x plus 3, a 0 of 0, and a 0 of 5. X minus 5, right? And then for a 0 of 0, it's just x. So f of x is equal to x times x plus 3 times x minus 5. For number 12, they have given us zeros, but they've also given us the multiplicity of each 0. Okay, so this 0 is -7, means it's x plus 7 with a multiplicity of 1, which you don't even need to include that 1 because it's assumed, right? And then 1 with a multiplicity of 2. So that's going to be x minus 1, but the multiplicity is 2, and it's a degree 3. So let's check that that's a degree 3. X minus 1 squared times x plus 7. What is that degree? We have a 2 and a 1. 2 plus 1 is 3, so that's done. So it's x minus 1 squared, x plus 7. Good? Number 13 says, for the given polynomial function, list each real 0 and its multiplicity. Okay? The way they ask you to answer this is kind of more complicated than the problem itself. Basically, the zeros, right? We took the zeros and turned them into factors. Now they're giving us factors and asking us to find the zeros. So for x minus 5, if I set that equal to 0, x would equal positive 5. So one real 0 is 5. And then the other one, x plus 4 equals 0. I'll subtract 4 from each side and get x equals -4 as my other 0. Good? -4 isn't a 0 because there's no x right there. Good? So there are two real zeros. The multiplicity of the larger 0. So the larger 0 is the 5. The multiplicity of 5 is 1. The larger 0 is 5. The multiplicity of the smaller 0, just because -4 is smaller than +5. The multiplicity of the smaller 0 is 2. That's the multiplicity. Multiplicity of x plus 4 is 2. Good? All right, continuing on. The larger x-intercept means exactly the same thing as the larger 0, okay? So the multiplicity of the larger x-intercept is 1. Remember that if you have odd multiplicity, an odd number, like 1, 3, 5, 7, 9, odd multiplicity means it crosses. Even multiplicity, 2, 4, 6, 8. Touches and then turns. Touches the x-axis and turns around, okay? So the graph touches or crosses the x-axis at the larger one. The larger one is 1. 1 is an odd number, so it crosses the x-axis at the larger intercept. The smaller x-intercept is just the smaller 0. If it's an even multiplicity, it touches. The next question is what is the maximum number of turning points on the graph? So let's look at this, okay? This is all one term, right? So we need to find what is the rule for the maximum number of turning points? Number of turning points is less than or equal to the degree minus 1 of the polynomial. Okay, so we need to find the degree of this polynomial. Here we have 2 and 1, so it's a degree 3. If it's a degree 3, 2 max turning points. Now it wants you to give the power function that the graph of f resembles for large values of x. Okay? What that means is if we turn that factored form into standard form, what would be the power function? Okay, so we've got f of x is equal to -4 times x minus 5 times x plus 4 squared. What I'm going to do is I'm going to put it into standard form. X minus 5 times x plus 4 times x plus 4. That would be x squared plus 4x plus 4x plus 16. We would see that that is going to get multiplied by that, so it's going to be x to the third. So -4x squared times x is going to give us x to the third. Good. And obviously for B, number 1, I wrote crosses, but you would just select crosses. Touches, touches for number 2. Good. So you can multiply all of this out, but really we just need the leading term. So the leading terms are going to be -4 times x squared. And you don't need the rest of the terms because that would take a lot of work. Good. All right, for number 14, they're asking us to graph the polynomial function f of x equals 16x minus x to the third. What you want to do is you want to put it in descending order. So I'm going to change it to f of x is equal to -x to the third plus 16x. We want the powers in descending order. A, determine the end behavior of the graph of the function. The graph of f behaves like y equals -x to the third. The first term for large values of absolute value of x. Find the x and y intercepts of the graph of the function. Remember, to find the x-intercepts, we set y equal to 0. So instead of f of x equals -x to the third plus 16x, I'm going to say y equals negative, what am I saying? The x-intercepts, oh, sorry, the x-intercepts. Y equals -x to the third plus 16x. I'm going to set that equal to 0. 0 equals -x to the third plus 16x. Okay, I'm going to factor out an x here. And I get 0 equals x times negative x squared plus 16. So now I have one factor, the factor of x, and then I have negative x squared plus 16. I'm going to factor out a negative 1 from that. Now I have x squared minus 16, because negative x squared divided by negative 1 gives me x squared, and positive 16 divided by negative 1 gives me negative 16. Now this is factorable, so I have 0 equals x, and 0 equals x squared minus 16, right? X squared minus 16, well, let's not do that, sorry. Let's take x squared minus 16 and put it into the factor of the difference of two squares. Sorry. So we have 0 equals x negative x times x squared minus 16. And that's going to become 0 equals negative x plus 4, x minus 4. Good. All right. So those are that's completely factored out. So I factored out an x. I factored out the negative 1. The negative 1 times that x makes it a negative x. And then x squared minus 16, that's a perfect square, and that's a perfect square. It's being subtracted, so I can change that from a squared minus b squared equals a plus b times a minus b. Good? Okay, so that means our factors are negative x equals 0, 0 equals x plus 4, and 0 equals x minus 4. When I solve each of these, 0 equals negative x. So x is 0. Here, x is negative 4. And here, x is 4. Good. So my 4 x-intercepts are negative 4, 0, and 4. Good. To find the y-intercept, we need to set x equal to 0. So that's generally a little bit easier. So it's y equals negative 0 to the third plus 16 times 0. Good. So y equals negative 0 to the third is just 0. And then 16 times 0 is 0. So 0. The y-intercept is 0. Good. Determine the zeros of the function and their multiplicity. The zeros of the function are going to be exactly the same as the x-intercepts. So it's negative 4, 0, and 4. What is the multiplicity? Sorry. Determine the zeros of the function and their multiplicity. So the equation I have is f of x is equal to negative x plus 4, x minus 4, right? All of those multiplicities are 1. So the smallest 0 is negative 4. It has a multiplicity of 1. Remember that odd multiplicities cross and even multiplicity touch. Odd multiplicities cross the x-axis at x equals negative 4. Okay? Our next one is the middle zero is a zero of multiplicity. 1. So the graph crosses the x-axis at x equals 0. Good. And then the largest zero, 4, has a multiplicity 1. So the graph crosses the x-axis at x equals 4. Good. Determine the maximum number of turning points on the graph of the function. It's a power of 3, so the maximum number of turning points is 2. 3 minus 1. Whatever your power is, minus 1 is the maximum number of turning points. So we need to draw a complete graph of the function using the graphing tools to graph the function. All right, we know our point, the y-intercept is at 0, 0, 0. The x-intercepts are -4, 0, and 4. And it behaves like negative x to the third. Okay? Negative x to the third is going to do that. Good. It's going to cross at each of these. So your graph is going to look like that. Complete graph. Sorry, complete graph of the function. If it's a complete graph, yeah, we've shown that it begins in a positive direction in the negative. It crosses at -4, goes down, comes back up at 0, goes up, comes back down at 4, and then goes on forever. Good. All right. Number 15 asks us to find the domain of the rational function. Find the domain. You want to say the domain is always all real numbers. So that would be from -infinity to infinity. Notice that they're asking you to answer in interval notation. So if the answer is all real numbers, you just say from -infinity to +infinity. But the domain needs to eliminate anything that would cause a fraction denominator to be equal to 0. Good. So here we have x minus 3. If I put in a 3 right here, that would equal 0, and 0 times whatever this is would equal 0. Okay? So x minus 3, set that equal to 0. X is 3, and so it cannot be 3. X plus 1, set that equal to 0. X cannot be -1. All right, so if I subtract 1 from each side, I get x equals -1 as what would give me 0 in the denominator. I don't want 0 in the denominator, so the domain is any number except -1 and +3. However, they're asking you to answer in interval notation, which is kind of a lot of work. -infinity up until, not including -1, united with -1 to +3, united with 3 to infinity. So because they're parentheses, it means we're not counting -1 and we're not counting 3, but you do have to write it like that. Okay? You can ignore the top. The top does not, unless you have something to factor out. Number 16, for the function f of x equals 7x squared minus 5 over x squared, graph the rational function using transformations and use the final graph to find the domain and range. Use the final graph to list any vertical, horizontal, or oblique asymptotes. All right, here is number 16. They're asking us for the function f of x equals 7x, the quantity 7x squared minus 5 divided by the quantity x squared. Graph the rational function using transformations and use the final graph to find the domain and range. and then use the final graph to list any vertical, horizontal, or oblique asymptotes. If you don't know how to graph the rational function using transformations, what I would suggest is putting in a value for x and solving for y, right? Because that will give us a point on the graph. So I'm just going to take, remember that f of x means y. So I'm going to say y equals 7x squared minus 5 over x squared. And I'm just going to say when x equals, let's do 1. Okay. So when x is 1, what will y be? Good. Y equals 7. Instead of x, I've got 1 squared minus 5 divided by 1 squared again. And then we're just going to solve it, simplify it. 1 squared is just 1. So 7 times 1 is 7 minus 5. 1 squared is 1. So that's 2 over 1 is equal to 2. So when x is equal to 1, y is equal to 2. So that gives us the point 1, 2. Good. Let's put that on each of those graphs, A, B, C, and D, and see if any of them match. And notice that they're counting by twos here. So 1 will be right here, 2 is right here. 1x, 2y is right there. 1x, 2y is right there. 1x, 2y is right there. Same on each of them, right? So we can eliminate C and D because those graphs are pretty far away. So it's either A or B. What you can do now is pick a point that is further out, like if x is equal to 10, will the answer be closer to 7 or closer to negative 7? Good. So we'll just do this again. Y equals 7x squared minus 5 over x squared when x is equal to 10. What is y? Y is equal to 7 times 10 squared minus 5 over 10 squared. So that's 700 minus 5, because 10 squared is 100 times 7 is 700 over 100. So that is 695 over 100, which translates to 6.95. When x is equal to 10, y is equal to 6.95. Let's find that on the graph. That point will be 10, comma 6.95. I'll go up to 10 and up to almost 7, 10 and up to almost 7. So it looks like it is the graph of B. And then they're going to ask, what is the domain of the given function? Remember that domain means the x, all possible x values. They're asking you to write it in interval notation. Interval notation is from negative infinity to positive infinity, for example, if it was all real numbers. But remember that to find the domain, you want to take the denominator, set it equal to 0, and find out what answers make it true, what values of x would make it equal to 0, and eliminate those. Okay? So make sure that's focused. So here our denominator is x squared. Set it equal to 0. You can even factor it out if you want. X squared is just x times x equal to 0. So we have x is equal to 0 and x is equal to 0. You solve them for x, which they already are, and you say it cannot be those two, which are the same. So the domain is all numbers except 0. The way we write that is from negative infinity to 0, united with 0 to infinity. Guess that one should be blue. Good. So that is the domain of the given function because it cannot be 0. If I put 0 in here, what happens when you divide, oops, happens when you divide by 0? It's an error. It's undefined. Good. So that's what we're trying to get rid of. Now for the range, it's a little bit more difficult. What we're going to do is solve for x, but the entire thing. Okay. So we've got y, I'm going to copy it down again, y equals 7x squared minus 5 over x squared. And I'm going to solve for x. We're going to start by taking, since it's a fraction, we're going to multiply both sides by the denominator to get rid of the fraction. So now we've got x squared y equals 7x squared minus 5, right? And if we are solving for x, that means we want to get all of the x's to one side. So now we've got x squared y minus 7x squared equals negative 5. Good. I'm going to factor out the x squared. And that becomes x squared y minus 7 equals negative 5. The x squared is being multiplied by y minus 7, so I'm going to divide it by y minus 7. Now we're going to do the same thing we did here, where we took the denominator and set it equal to 0 and say, what can it not be? So our denominator was y minus 7. Equals 0. So if I add 7 to both sides, y equals 7. So that is the one thing it cannot be. So that means that the range is, okay, for the range, they say use the graph to find the domain in the range. So the range is all, if we just look at the graph, right? If we look at the graph, we see that there is a gap and it's probably at 0. So we did it algebraically. But you can also just look at the graph and determine based on the graph. So it ends, right? It does not go higher than 7, but it goes down forever. So that would be negative infinity to 7 for our range. From negative infinity to 7. Remember, it does not include 7 because it will never touch the horizontal asymptote. It will never touch that line. It will approach it. Okay? And then it's asking what is or what are the vertical asymptotes? So you can see that the line is going forever in an attempt to get very close to but never touch y equals 7. I think I wrote them in the wrong place though. There's not two, sorry, the vertical asymptote. Vertical asymptote, where is it approaching? All right, guys, this is number 16. They're asking us to graph the rational function It says using transformations, but I think the easiest route is if you have the multiple choice here, is to find a point, a value for x, and input that value into the equation. Remember that f of x is equal to y. So put in a value for x, find the y, and plot that point and see which of the graphs your point matches. Okay? So we've got y equals 7x squared minus 5 over x squared. I try to keep it as simple as possible. When you look at this, you don't want to pick 0 because 0 is where the graph doesn't really give us enough information. So I'm going to pick when x equals 1. What is going to happen to y? So we've got y equals 7 times 1 squared minus 5 divided by 1 squared. Good? We'll just solve that. 1 squared is 1 times 7 is 7 minus 5 over 1, which is 2 over 1. So y equals 2 when x equals 1. We know that point can be written as 1, 2. And then we just graph that point and see which of the graphs that matches. Notice that they're counting by 2. So that's 10, 10. So that would be 1, 2. 1, 2. Here and here. So I plotted the same point on each graph, on each coordinate plane. It does not cross C and it does not cross D. So we just have to eliminate, is it A or B? Okay. Um, a good way to do that is to just pick a second point. So I'm going to pick the point x equals, and then try to see where there's a difference. So when x equals 10 here, y is going to equal negative something, right? When x equals 10 here, it's going to be positive something. So I'm going to input 10 as my x value. Y equals 7 times 10 squared minus 5 divided by 10 squared. So that is going to give me 700 minus 5 over 100. Sorry, I should have used a different color to differentiate from over here. 700 minus 5 over 100, which is 695 divided by 100, which is 6.95. And that is a positive number. So that point would be 6.9510, right? So we'll go over, sorry, x is 10. I wrote that backwards. We'll go over 10 up 6.95. Over 10 up 6.95, over 10 up 6.95. So we see that it is the graph B as the correct graph. And then it says use the final graph to find the domain and range. So we're just using the graph. We're not going to use algebra, even though you could do that. So the domain is all numbers except where would the asymptote be? The asymptote is going to be at 0. So domain is usually, if it was everything, if there was not an asymptote, it would be negative infinity to positive infinity. But here we have an asymptote right at 0. You can test this by setting x equal to 0 and, or no, sorry. You can solve that by taking the denominator, right? And setting it equal to 0 and solving for x. So x squared equals 0. X squared you can even factor into x times x equals 0. Take each of those, x equals 0 and x equals 0. Solve them for x, which they already are, and then eliminate those, right? So the domain is all numbers except 0. The way you write that is we start with that same domain, all real numbers, but then we stop at 0. We do not include it, so it's not a bracket, it's parentheses. United with 0 to positive infinity. That's for the domain, okay? For the range, we're just going to look at what that number is that it's approaching but never touching, and that number is 7. So we're going to say the range is from negative infinity because it starts way down here with an arrow, right? Up to 7. Never touching it. Good? Okay. And for the vertical asymptote, just remember vertical means like this. Horizontal would be like this, right? So the vertical asymptote, they asked us to just use the graph. The vertical asymptote we determined is right at x equals 0. Good? I put that in the wrong spot. It's not the left vertical asymptote and the right vertical asymptote because that has two boxes. You can't really see on the PDF, but so I wrote that in the wrong spot. There is one vertical asymptote. It is at x equals 0, or it is x equals 0. Good? And then what are the horizontal asymptote? Remember, the horizontal asymptote is going to be right here where the graph approaches and never touches. So the horizontal asymptote is y equals positive 7. Good? If there is a horizontal asymptote, you cannot have an oblique asymptote. So you would say there is no oblique asymptote. There is one horizontal asymptote and there is one vertical asymptote. Good? Okay. Number 17, again, they're asking us to find the vertical, horizontal, and oblique asymptotes, but they have not given us the graph. Okay, so now we're going to do it algebraically. How do you find a vertical asymptote? You want to factor the numerator and the denominator. Here our rational function is just 6x divided by x plus 3, so we cannot factor either of those. They're already in their simplest form. And then take the numerator, sorry, take the denominator and set it equal to 0, and that will be your vertical asymptote. So when x plus 5 equals 0, what is x? So we're going to solve for x. We're going to subtract 5 from both sides, and we're going to say x equals negative 5 as our vertical asymptote. Right? Because it cannot be. Negative 5 plus 5 is 0, so that is a place the graph cannot exist. For your horizontal asymptote, remember you want to line up the powers of the numerator and the denominator and compare the powers, okay, of the leading term. The power or the degree of the leading term of the numerator and the denominator. So we have 6x over x. You can ignore the plus 5, right? Just the leading terms. And so we have a power or a degree of 1 on the top and a degree of 1 on the bottom. If that top, if the numerator, here are the rules. If the degree of your numerator is less than your denominator, the horizontal asymptote is at y equals 0, which is the x-axis. If they are the same, which is the case we have here, the horizontal asymptote is at y equals a over b. And then the third situation is if the numerator is bigger than the denominator, there is none. Okay? So those degrees are the same. It's 1 over 1. So you're going to find an equation, or sorry, you're going to find a numerical value of y. So y equals, and we have a 6x and a 1. You just take the terms in front of the x. So that's a 6. There's nothing in front of this x, so it's going to be 1. So it's equal to 6 over 1. Anything divided by 1 is itself. So it has one horizontal asymptote at y equals positive 6. Good? Okay. If it has a horizontal asymptote, it cannot have an oblique asymptote. So you do not even need to think about how you would find that because you found a horizontal asymptote instead. Okay, for number 18, they don't give us the equation of the function. They just give us the graph. Okay? So what would the domain and range of this graph be? Domain are x values. So we start over here like it's on just on the x value. We start over here. It does have an arrow going towards negative infinity. It does have an arrow going towards positive infinity on this side too. However, it stops. It stops right here, which is at positive 4. Okay, so it's going to be from negative infinity to 4, united with, because it continues after that, but up here, 4, and then that goes on forever in this direction, positive infinity. So I'm going to say the domain of the function is negative infinity to positive 4, united with 4 to positive infinity. Good. The range are the y values, and we're just going to do the same thing. Remember, you always start at the negative. So negative, it is going to negative infinity. Does it stop anywhere? It stops right here at positive 3. And then it continues after 3 and goes to infinity. So that is the range of the function. And then find any intercepts. Remember, an intercept is where it crosses either x or y. Our intercept in this case is right here at the origin. The origin is the point 0, 0. There might be two, so you would do 0, 0, comma, and then your next one. Good. Find the horizontal asymptotes. So here they're asking for horizontal before vertical. The horizontal asymptote, we already counted that. That's up to 1, 2, 3. The horizontal asymptote is at y equals 3. And vertical asymptote is just up and down. Vertical asymptote is at x equals 4, right? If it has a horizontal asymptote, it will not have an oblique asymptote. We'll do it again. Use the graph shown to find the domain and the range. The domain are the x values. So if it just ends, that does mean an arrow. So it starts at negative infinity. It stops at positive 2. It continues after positive 2 and goes forever in the positive direction. The range are the y values. So start at the bottom. There are no arrows or graph ending at the bottom. So we're going to count up to 1. It starts at 1. And this goes off the graph, so that is a positive. So 1 to infinity for the range. Good. For the intercept, it just gives us the intercept at 0, 2. And then it asks us to find the horizontal asymptote. Horizontal means it's flat, right? Like the horizon. The horizontal asymptote is at y equals 1. Vertical asymptote, up and down, that's at x equals 2. And if it has a horizontal asymptote, it will not have an oblique asymptote. Okay, for number 20, it says for the function h of x equals negative 4 divided by x plus 1, graph the rational function. So it's similar to number 16, I think it was. choose the correct graph. It's given us 4 graphs. I'm going to find where the value of y when x equals 1. Okay? So remember, h of x is equal to y. So y equals -4 divided by x plus 1. I'm going to rewrite it as 1 plus 1. -4 over 2, which is -2. So when x is 1, y is -2. So that's the point 1, -2. See which of those graphs it touches. Again, we're counting by twos. So 1, -2, 1, -2, 1, negative. Oh my gosh, Lord. 1, -2, 1, -2. All right, so it appears to only be touching on D. You can test it again just to be sure. So I'll put in when x is equal to, let's see, it would be between this one. It's not that one, right? It would be another good point to choose. When x equals maybe -1, right? Because then we'll know if it's down here or up here. When x equals -1, y equals -4 divided by -1 plus 1. So it will not exist when x equals -1. So that will be the asymptote, which could be true for that one. Here at -1, you would have this point. So that's not the asymptote, so we're going to eliminate B. Here, -1, it would be right here, and that's not the asymptote, so we're going to eliminate A. If you find the asymptote and you find it confusing, sorry, you can pick a different point. Like I can try -2. X equals -2. What is y? Y equals -4 divided by -2 plus 1 is -4 over -1, which is a +4. So when x is equal to -2, y is equal to 4, so that'll give me the point -2, 4. -2 up to 4 is right there. 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 Good? So it could be B or D based on that point and that point. That point, it's a little bit off, but it could be, right? So then you could just say, all right, that's when you would have to decide about the asymptote. So this asymptote is at -1, right? And this asymptote looks like it's at +1. So we'll say, or +1. Yeah, so we already did that. If it was +1, it would be -2 and the asymptote would not be there. So we're going to pick D. Good. The domain of the function is all of the numbers except anything that would make x equal or make the denominator equal to 0. So if x here was -1, -1 plus 1 would equal 0. So the domain is all numbers except -1. Good. The range of the function The range is all of the y values. It's everything except y equals 0, because that's where the other asymptote is. So from negative infinity to 0, and then 0 to positive infinity. Good. What is the vertical asymptote? Vertical is up and down. So the vertical asymptote was at the vertical asymptote was at -1, because when it was -1, we got 0 in the denominator. So x equals -1. For the horizontal asymptote, it's at y equals 0. If there is a horizontal asymptote, there will be no oblique asymptote. And that is the end of the rational functions. So now we're just going to solve the system of equations. When you solve it, it means that you are finding the point where those two meet. This looks like a good example that we could solve by substitution. However, you do see a graph right here, and it says use the graphing tool to graph the line. So if you want to just graph it and find that point, that's also fine. But I will show you how to solve using substitution, okay? So we have x plus y equals 8, and we have x minus y equals 4, right? What you want to do is you want to solve one of these for one of the variables, isolate one of those two variables, either x or y, in either one of the equations, okay? I like positive numbers, so I'm going to isolate x in this equation by adding y to both sides. And we get x equals y plus 4. And then we're going to put that in for x, and we will be able to solve for y. Good? So I take this and put it in here. So instead of x plus y equals 8, I have y plus 4 plus y equals 8. You do not need the parentheses. I just like to use parentheses when I substitute anything. So y plus 4 plus y equals 8. Combine the like terms. So now I have, instead of 1y plus 1y, I have 2y plus 4 equals 8. I'm going to isolate y now, solve for y. Subtract 4 from both sides, and I get 2y equals 8 minus that 4 is 4. Divide by 2, and I get y equals 2. So that is what y equals for the solution, if it has one solution. So what I'm going to do is I'm going to put that 2 back into either one of these equations for y and solve for x, okay? Does not matter which one you pick. X minus y, but we know y is 2, equals 4. So we have x minus 2 equals 4. Add 2 to both sides, and we have x equals 6. So the point where they cross is the point 6, 2. And it does not matter if you had used that one or that one at the beginning, or if you had solved for x or for y. I just tried to pick the easiest one. So it's the point 6, 2, x equals 6, y equals 2, which is that point. So when we graph it, hopefully they will both cross right there. So we have x plus y equals 8. You can graph it however you like. I like to set it equal to y so I know where to start on the y-intercept. So x plus y equals 8. Solve it for y by subtracting the x. So y equals negative x plus 8, right? That means the graph starts at, this is my y-intercept. It's been a while since we've graphed. And then this is my slope. So it's going to cross the y at 8. And then the slope is going to be down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And we see that it does run right into that point that we found that we have chosen as the answer to the system. So I would graph that. And then just take the second equation. It was x minus y equals 4. Solve it for y. I might move that y so I don't have to divide by -1. So I'm going to move that y over. I'm subtracting y, so I'm adding to both sides. Y equals 4 plus x equals 4 plus y. Now I'm going to subtract that 4 from both sides. X minus 4 equals y. Or y equals x minus 4. Same thing. This is my slope. This is my y-intercept. So I'm going to find -4. And then I'm going to go 1. Up 1 over 1. Up 1 over 1. And I see that both of those lines cross the point that I said was the answer to the system of equations. Good. Here, they are not asking us to graph. So we can again use substitution. We have 2x minus 5y equals -18. And then we have 5x plus y equals 9. Again, you can start with either equation and either variable. It looks like this would be the easiest, right? So I'm just going to subtract 5x from both sides, and I get y equals -5x plus 9. Sorry for putting a curl on that 9. Put that in here for y. So here we had 2x minus 5 times 5x minus 9 equals -18. Good. Now I'm going to distribute the -5. -5 times a +5 is a -25x. -5 times a -9 is a +45 equals -18. Combine your like terms. 2x minus 25x is a -23x plus 45 equals -18. Subtract that 45 from both sides. So -18 minus 45 is -63. Divide both sides by -23 to get x alone. -63 divided by -23. Don't love that. All right, so my x is -63 divided by -23, which I guess is positive, right? 63 23rds. Oh, thank goodness I made a mistake, guys. All right. It's like, I don't want to do this anymore. It was a -5 and I didn't make it a -5. Ignore all of that. I'm going to take this y, put it in for the 5, put it in next to the 5. So what I've got instead is 2x minus 5 times -5x plus 9 equals -18. That was all wrong. I put in a +5 and a -9. Sorry if you caught that before me. You probably caught that way before me. Distribute that -5. 2x. -5 times a -5 is a plus 25x. -5 times a +9 is -45. equals negative 18. Now we're going to combine like terms and we get 27x, hopefully, minus 45 equals negative 18. Negative 18 plus 45 is just 27. So now it's 27x equals a positive 27 because we added 45 to both sides. Divide by 27, divide by 27, and I get x equals 1, right? Now I go back and I put that into either one of the original equations, x equals 1. So we know x equals 1. Decide if it looks easier there or there. I'm going to do this one. So I have 5 times 1 plus y equals 9. 5 plus y equals 9. Subtract 5 from both sides and I get y equals 4. And so that's the solution to that system of equations is x equals 1, y equals 4, which is the point 1, 4. Good? All right, number 23 says the same thing, solve the system of equations. If it has no solution, say it is inconsistent. X plus 4y equals 8 and 5x plus 20y equals 40. I'm going to solve this one for x, so I'll just subtract that 4y from both sides and I get x equals negative 4y plus 8. And I will put that in for x right here correctly, hopefully this time. 5 times negative 4y plus 8 plus 20y equals 40. 5 times negative 4 is a negative 20y. 5 times 8 is a positive 40. Plus 20y equals 40. Good. Now I've got negative 20y plus 20y knocks out my y, so I have 0y plus 40 equals 40. Good. 0y just goes away and I have 40 equals 40. Or you could even say 0y plus 40 equals 40. So I will subtract 40 from that side to 0y equals 0. Either way, this is true. This is true no matter how I manipulate it. It's always true. And there's no y to translate into here. Okay? You can even solve for y, which would be easier to solve for y. That one, x plus 4y equals 8. Subtract the x, so I've got 4y equals negative x plus 8. Divide by 4. Divide by 4. That's not going to be fun. Oh, sorry, that's a y. Y equals negative x over 4 plus 2. Put that into there. 5x plus 20 times negative x to the 4th plus 2 equals 40. So I'm just making sure it fell out here, right? Which implies if it's always true, it means there are infinitely many solutions, but I'm just going to try with x to make sure that that's true here too. So here we've got 5x plus 20 times negative x over 4 is 20x over 4, but it's negative, right? That negative makes this negative. And then 20 times 2 is 40 equals 40. 5x Negative 20 divided by 4 is a negative 5x plus 40 equals 40. 5x minus 5x is 0x plus 40 equals 40. So we're in the same situation as we were over here, or 0x equals, subtract 40 from both sides, 0. So that is all infinitely many solutions. If you graphed those, they would be the same graph. You can tell because this is just this times 5. So if you took x plus 4y equals 8 and multiplied it all by 5, you'd get 5x plus 20y equals 40. So it's the same line. The system is inconsistent if you eliminate the y, and this is not true. If it was negative 20y plus 20y plus 30 instead of 40, then that would be it is inconsistent there. Sorry, it is inconsistent. There is no answer. So if it's true, if your variables fall out and it is a true statement, like 40 equals 40 or 0 equals 0, then that is infinitely many. If it falls out, you eliminate your variable, but it's not true. Negative y plus 5 equals 10, right? Sorry. Negative y plus 5 equals 10. You eliminate those because they cancel out and you get 5 equals 10. That is inconsistent. That's when you would use this answer. Last one, number 24. Solve the system by the addition method. So it does not matter if you use the addition method or not, but because the exam won't know, right? How you got your answer. But I will do the addition method just because it tells me to, so that you can see it. All right, here we've got negative 6x plus minus 8y equals 1. And then our second equation is 42x plus 56y equals negative 6. But the addition method just basically means you're going to add these, right? But you need to add them in a way that eliminates either the x's or the y's, okay? So we want to think, we have negatives here and positives here. That's good. Is there a way to go from 6 to 42? I think there is, right? Because 6 times 7, sorry, you couldn't see that. 6 times 7 is 42. So I'm going to take that top, the entire equation, all three parts of it, just like we did over here to confirm. We multiplied it by 5 and we got the exact same equation. So if we were to add those, right, and make it negative, if you multiplied it by negative 5, let's do that. Multiplied it by negative 5, you'd get negative 5x minus 20y equals negative 40. And then use the addition method. Those would cancel. Those would cancel. Those would cancel. So here we're going to take the top and we're going to multiply it by 7 because it's already negative. Good. So now we have negative 42x minus 8 times 7 is 56. 56y equals 1 times 7 is just 7. Our other one is positive 42x plus 56y equals negative 6. Now we're just going to add them. Negative 42x and 42x give me 0x. Negative 56x plus negative 56y plus 56y gives me 0y. However, 7 minus 6 gives me a 1. So this is not consistent. That means there is no solution. And remember, sometimes it'll be written as there's no solution. Sometimes it'll be written as the system is inconsistent. That's the addition method. And that is the end of your exam study guide. Thank you so much for watching, and please email me if you have any questions.